Hey guys, my name is Saeb and welcome to episode 26, which is the last episode of this series. Yes, we're done. And that's why I think you're seeing me. In this episode, we're going to build a game with PixiJS, which is, as I said, going to be a graphically rich one, more than the previous two games, the Bong and the Roll the Dice. But I feel like each game of these three games that we're going to build have some concepts or some things that are related, that are different from each other. That's why I wanted to change the things for each game so that you actually learn a new thing. But yeah, we're gonna see how Bixby exactly eases a lot of things for us, from rendering to taking inputs to dealing with everything in our game and to changing between the scenes of the game, the levels, and even it's gonna be much easier and it's gonna save us a lot of effort and a lot of time, and you're gonna see that now. So I truly suggest using Bixby if you want to build games, if you want to continue doing the web games, because honestly I'm not into web games a lot. I'm more into console and PC games, and especially with C++. So I think I won't be extending this series, or I won't be doing any other thing that's related to the web. I think I'm gonna move on to C++, but I thought if I started with Canvas, since I feel like this is the easiest technology you can use to build games, and to be honest, this is a good introduction to game development, this series was. And we're gonna build this game from scratch using PixiJS, and we're gonna see all of the things related to them. So I'm just gonna explain the game design of this game. So we have a hunter, which is that one that's moving freely around our canvas. Of course, it's contained in this area. We use the contain function that we've built in the previous episode, and for the movement, it's the custom keyboard function. So we are actually building from the previous episodes that we've done. So I think if you haven't watched them, I think you should, because I'm not going to be explaining again, since this is a series that's connected to each other. Every episode is like a build up to the previous one. So and of course I'm having to move. I have these blobs, or the monsters that represents the enemy in our game, so I have to avoid them and move to get my chest or the treasure in here. So now it's gonna be stuck into me, and then I'm just gonna go and move my hunter like this. I have to avoid them if I got hit by one. Okay, let's just get hit by one. You can see that my portion of my health is decreased a portion, and I have to go back to the door, and I won. The other case is that if I lost, I'm just gonna keep hitting myself with these blobs of the monsters, and I lost. Of course, we can change the number of these blobs. We can increase them. We can change the speed to make them faster or even slower. You can extend this game to make it more for levels thing. It's easier to do this. You're gonna see how we're gonna use the game scenes to change from the gameplay scene to this scene, which is the end one. And you're gonna see the power of Pixie in here and how we can actually do it. This game I found from a book which is called PixiJS, I think. Learn PixiJS. I'm gonna leave a reference to that in the description if you want to increase if you want to learn PixiJS like in a much more detailed way, to cover all of the things in PixiJS. So I hope this will be an informative episode and a great end to the series, and I'll see you when we're actually gonna build this game from scratch. This is the template that we've been using since we started using PixiJS. We have our render in here and a size of 800 by 600. This is the background, which is a white one. Again, you should use a hex 0x that represents the hash. So make sure that you're at 0x, and then you can use the hex values, same as we did in the colors episode or any of the previous episodes. And we have to we centered our canvas that was in the previous episodes. You can check that one if you didn't understand that one. And we have our border, which is a dashed one. I think I'm gonna remove that one, but let's keep it for now. And we have our stage, which is a container, and this is the loader to load the assets, and this is the resources to access them. And this is our setup function and our game loop, and we make sure that we have a state in order to change between the game scenes and the game levels. And in this game you're gonna feel the power of states and how states are really a good things to follow. Game states are good things to follow and use. So I'm gonna have two states, the play one and of course an end one. So I'm gonna make a function for the end one that represents the end state when we lose or win. For now I'm gonna leave it empty, but then we're gonna change that like an end under a certain condition. So let's go to the HTML. Let's name our game. Let's call it treasurehunter, hunter like this, and I'm gonna save. And I'm using the minified version and the PixiJS, which is this one that I used. And okay, so the first thing that we're gonna need is to let's resize our canvas, because I have a field of 800 by 557, I think. So yeah, I'm gonna change this to 557. I'm gonna talk about this more when we get to the field. And okay, so now we changed our canvas size. The first thing we're gonna do is, of course, we're gonna load our assets. So yeah, I'm gonna go to the loader, and I'm gonna click on add, and I'm gonna use an array since I'll be using a lot of assets. I'm having assets here in the treasure hunt, which is this file, and I'm having like 5 assets that I should upload, so or should load. So yeah, I'm gonna have an array. I told you in the first episode, the big introduction one, we can add an array simply by doing this. This is a file, and then another one, that one. So I'm gonna have 5 assets that I'll be using, and of course this is the last one. So I'm gonna have to give it a location now. So I'm gonna say assets. It's in my treasure hunt file, and it's gonna be the first one we need is the field bng like this. And now I'm gonna have to copy all of those to the other assets so that we can load them very easily, same as we did in the previous episodes. Nothing new until now. And I'm gonna have the explorer, which is the hunter in our case, and then I'm gonna have the door, and then the blob, which is the enemy, the monsters. Of course, we're gonna make an array for these blobs to add as many as we want in a random locations or random x and y values. And the last one is the treasure, that if I got to, I'm gonna win the game, and I have to take it to the door to leave the dungeon or this field. Okay, so if I loaded my assets, then I'm just gonna say load setup function to set up our own function and everything. So until now everything is good, nothing is new. We've done all of this before. And now before I'm going to set up, I'm gonna have some global variables that are gonna be used in more than one function. So I'm gonna define them up here, not inside a function, since I told you the let keyword, or the variable one, the let one specifically, have a block scope, which means that if it's defined into this inside this function, we can't access it from outside. So since I'll be using these variables such as the explorer, for instance, in many functions, I have to define them as global variables outside of our functions in our main JS file like this. Okay, so for the variables, the first thing is going to be the field, which is the playground, and then I'm going to have the explorer. Of course, I'm going to have a door that I have to reach in order to win the game, and I have a treasure, which is the chest, and I'm going to have a health bar, which is health bar like this, like that one, health bar. And this is the camel case convention, the naming. It's actually a good one. If you're having a new word, you have to make it capitalized at first. You should also follow that one. It's a more clear code. I suggest that you do that. It's fine, you can do whatever you want, but I suggest that you do so. And then I have my health bar. I'm gonna have a message that shows at the end to specify either we won or we lost, and I'm gonna have 2 game scenes. The first one, which is the game scene, the scene that we actually play with, and the other one is the game over, like this. Let's call it game over scene. So it's gonna be game scene and game over scene. These are all of the variables that we're gonna need. So in the setup function, the first thing I'm gonna do is I'm gonna load my field into this area. So I'm gonna have this, I'm gonna remove the dash now, but I'm gonna make sure that we have our field and then we remove it. So since the background of this canvas is white, we don't want to get lost. Okay, so the first thing I'm gonna specify is a game scene, and I'm just gonna say new Pixi container. We've talked about containers before. I told you that Pixi requires us to have at least 1 container, which is the stage 1. That's the 1 container. Now we're gonna use the stage as a main container that has 2 containers that represent a scene, each scene in our game. So I'm gonna add this game scene into my stage, simply as add child like this, and I'm just gonna say game scene. And now I'm gonna put every visible thing in my game in the game scene, and I'm gonna put the message in the other container, which is the game over scene. And I can change between these scenes using the game state. I hope that makes sense. Now we're gonna show you how. but yeah, that's it. So now I'm gonna load the field inside my game scene, and I want to render this game scene. By default, this game scene visible is gonna be game scene dot visible. That we've talked about is true. That means it's gonna be visible, but I'm gonna change the visibility of the game over scene into false, so that we don't actually see it until we reach the end state, which is in the function here. Okay, so far so good. Everything is exactly, nothing is new until now except the game scenes and how we can change them, but we've talked about in the previous episode. And okay, so now let's do the field. And now I'm going to show you a new method of how we can actually create a sprite directly from using the new Pixi sprite, and I can do from. Now this from is going to convert this image into a texture by default directly without needing to access the resources and everything. So the way we did this before, we said let field sprite like that, and then we made a resources like that, and then we access these resources giving the name, which is the location of that one, which is the field like this, and then we convert this into a texture, and then we pass the sprite into the new sprite like this, and we're gonna have our own field. But now what we're gonna do is a simple direct method, which is sprite, and we can use from that will convert this image into a texture directly. So yeah, I'm gonna have this field now. I'm gonna copy its name, which is represents the location of it, and I'm gonna, okay, I didn't got the quotation marks, so I'm just gonna delete it. Okay, now I have my field, so I'm gonna put my field into my game scene. As I said, it's gonna be in the game scene, so that when we have the game over, we have only the message. That's why we change between scenes and everything. That's the good thing about Pixi. And yeah, so I'm gonna do now is I'm gonna add child, which is the field. Now I should see this, since I'm in the game loop, I'm rendering my stage, which has the game scene. So I'm gonna look at it. I'm having my game scene, which is the field. By the way, this field, I created this with Photoshop. You can see that it's really bad, even at the ends like this. But I got the textures from the Craft Pix, the same site that we got the sprites in the sprites episode. So I searched for dungeon, I think. I went to the last page, which was that one, dungeon platformer, and I used some of the grounds in here to actually build this one. So you can see it's the same, but I did it with Photoshop. And yeah, you can see it as it's bad, but it's okay. It's a field. I want it to be wider than the book's game, because this game was taken from a book. I'm gonna leave a reference to that in the description, of course, but I made it wider, so I made it my own field. But it's okay, you can use it. I'm gonna leave it in my GitHub as well, or you can use your create your own in Photoshop, and you can customize it and design it the way that you want. For the details, I think these are the traps. This actually does nothing, it's just to confuse the player, but it's just for the details. And yeah, okay, so now we added the field. Let's add the door. We're gonna do it the same way, so I'm gonna copy that one just to save time, and it's gonna be the door. Now I'm gonna give an x and y coordinates for the door. Okay, for the x, I want it to be 20, or maybe 30. 30 is fine. And door dot y is supposed to be 10. Make it down a bit, and then I'm gonna add this to my game scene. So I'm gonna add child, and it's gonna be door. And now I'm supposed to see my door in here, which is that one. I can take that down a bit by increasing the y, so I can just say 12 for that. Okay, this seems good. And now let's add the treasure, which is the chest. So the way we do this is I'm gonna go to treasure. Let's copy this everything, because it's gonna be the same. I have to name treasure, which is these global variables, so that I can access them in more than this function, more than the setup function. Now I'm just gonna copy that, and I'm gonna add it in here, and then I'm gonna specify an x and y for that. I want it to be at the end of my canvas. This is an 800 by 557, which is the dimensions of my field that I did in Photoshop. So yeah, that's why I got this. I resized my canvas. So now we can comment, I think, the dash border. Doesn't actually, it looks better with the dashed, but I don't know. I think we can keep it. It's fine. I don't know why I think it looks nicer in the dashed one. Okay, so let's put the chest in here, or the treasure. So we can just say dot x can be 710, and for the treasure dot y it's gonna be 510, for instance. make it at the end. Now game scene, I'm gonna add child, and it's gonna be treasure, and now I'm gonna see my treasure at the end. Okay, this is good, seems to be good. Maybe we can shift that to the right a bit, but it's fine, it's good. And now we're gonna have the explorer, which is the player, so it's gonna be a new Pixie sprite from, and it's gonna be simply the explorer, that one. So you can see how easy this is. I think it's just have to deal with the assets and things. I'm not good with building assets and everything. I usually get it from online. But yeah, so we have to specify the X, which is 60. And for the Y, I want to center this in the Y, so simply we can center it very easily the way that we did in the previous episodes. We can take the render view, height divided by 2, and I'm gonna minus that with the explorer height divided by 2. I've explained that a lot. Since we wanted this to be centered exactly in the vertical one, I put that one in the center of our canvas vertically, and then I divided this by half the height of the explorer so that it's exactly in the center. And yeah, I have to add it to the game scene so I can actually see it. Dot add child, it's gonna be explore, like this. You can see now it's exactly in the center, like that. And I pushed it into the horizontal one so that it's up there, and the front like this. And since this explorer will be moving, so I think we should introduce 2 new variables, which are the velocity x, which is 0 for now, and we can have the velocity y. Since every axis, as I said, requires its own velocity and its own acceleration, its own friction, we won't be using any physics in here since this is a simple movement. And yeah, this is everything for the explorer. So now let's do the blobs, which are the monsters or the enemy that are gonna be moving randomly in our case in here. So the first thing I'm gonna do for that is I'm gonna define some variables. So let's say the first thing is the number of blobs or monsters. So I want them to be, let's make them 10. 10 is fine, and I can use this comma to specify or to define different variables. And okay, so now we have 10 blobs or 10 monsters. And then I'm gonna specify speed, for instance, it's gonna be 2. And then I'm gonna specify speed. This is the speed of their movement, which is the displacement. This represents like a velocity for the explorer, but it's for the blobs. And the direction is gonna be 1. Now the way I'm gonna use this direction is to reverse this direction so that one moves up and one moves down. That is the idea of it. So yeah, I hope this makes sense. And now let's define an array. So okay, that one should be common. Now I'm gonna make the blobs in here. I think I should just make blobs like that. I didn't even mention that in here, so it's gonna be blobs like this, which is gonna be an array. Blobs, and I'm gonna make them an array like that, so that I can add into this blob. So I'm gonna make an for statement so that I can have as many blobs as the number I specified in here that represents the number of iterations to create each blob. So it's gonna be, I'm gonna say let I, which represents the index, I is lesser than the number of blobs, so that I can easily change it if I want, but just by changing the number of blobs in here. And then what I'm gonna do in here is simply I'm just gonna say I'm gonna add it, this condition, so that I have every time a new blobs like this. Of course I think I have to specify an offset, or maybe a spacing between those everything. So I could just say spacing in here, and I have to specify this, make the spacing 48, seems fine for the spacing between every blob and the other. So yeah, and these ticks. Okay, now the first thing I'm gonna do is I'm gonna get the blob texture, which is the blob in here, that one. So I'm gonna copy the name. I think I had to copy the everything. Let's make it faster. It's gonna be const blob, and then new Pixie sprite from, and I can pass in the name like this. Now I have my texture ready to be drawn, and I'm gonna push that into a blobs array to represent all of the blobs. But now I have to give them some values, x and y. Okay, so for the X, it's gonna be, I'm gonna have the offset. I think we specified an offset. Okay, I think we should specify an offset in here. X offset. And we can give the offset of 0. It can be, we can make it 300 for instance. That goes from the 0 one, the offset from 0 from here to that way. And yeah, so it's gonna be the offset, it's gonna be plus the spacing, and I'm gonna multiply this by I. Now this way, this is actually very simple. I'm gonna make an offset which goes from the beginning of our canvas, if I fill in here, it goes into this point, and then I'm gonna make spacing between each two of the blobs. I hope that makes sense. Everything is easy so far. Now for the Y, I'm gonna make a function for the Y that puts them randomly. So I'm just gonna go up there, down there, and I'm gonna make a function. I'm gonna call it random integer, and I'm gonna have a min value and a max value, and then I'm gonna return math floor, and then math.random. I hope that everything should make sense now. Since we've talked about all of this, the math floor, since the math random returns a floating point, I have to make them integers by using the math floor, so that we have a certain value that's not a floating point, that is decimal, as I said. And the way we want it between this minimum and max, so the first thing I have to specify is the min, so that it goes from the minimum value, and now we have to make it until the max one. So the way we do this is simply we random that one and we multiply that one by max minus minimum plus 1. This is an algorithm that we can use in order to make we have a random integer from the minimum until the max, since those two are going to represent. So if I call it in here so that you understand it, it's going to be random like this, and it's going to be from 0, which is the Y, for top left is that one, 0 up until the render view height minus the blob dot height, like this, very easily, so that it goes from the beginning of our canvas until the end, but not exactly the end until that one, so that it doesn't go outside of our canvas, so that it's just in the range of the vertical canvas that we have. Okay, so that's the random int assembly and the implementation of this random int. If you clicked on it, you can see that we have our value from the minimum to the maximum. We've gone through random and floor. If you didn't know that, you should check Roll the Dice game. It explains everything about having a random value from certain value to the other. So yeah, we've gone through that a lot. And now let's go through, let's assign the blob x and y. X is gonna be x, and blob dot y is gonna be y. It's gonna be y like this. And now for the velocity, so I'm gonna have a velocity y. I can just say vy still, and it's gonna be the speed multiplied by the direction. As I said, the direction is just to specify the direction of the moving of these blobs, so that it's exactly one goes up, the other goes down. So the way we do this is that we alter the direction every time. I'm gonna multiply this by -1, so if it's negative, it's gonna be positive. If it's a positive, it's gonna be negative, to change the behavior of any two successive blobs. I hope that makes sense. And simply I'm gonna push every blob into this blob array, and lastly I'm just gonna add them into my game scene. And now I should see them actually after I okay, it's gonna be blob like this. Okay, that is good. I think I should decrease the offset, since this is actually a lot. So I can just say 100 for instance. It goes from 0, and no, I think 150 works fine. Maybe 200, I think. 200 is good. Now if I want them to move, I have to alter that in the gameplay, which has the logic that I'm gonna increase the x and y for each one. So the way we do this is actually very simple. I'm gonna go into the play, but maybe you can do that after the we can set up the function play for everything after everything. Okay, so let's, I think for now I'm just gonna go and alter the behavior of the Explorer so that we make it move very easily. And okay, so I'm just gonna go in here. I'm gonna have the keys, so I'm just gonna say constant left equals to keyboard. I'm gonna use the custom keyboard function that we've been using in the previous 2 episodes, that one. This is really a great function that allows us to take inputs very easily and deal with them. And okay, so I'm gonna have, and to pass in the key code now, it's gonna be arrow left. Make sure you write exactly the same one. You can do a console log the event to check for each key, same as I showed you in the previous episode, the keyboard one. And now it's gonna be for the right one, and it's gonna be keyboard arrow right. I'm gonna fast code this one since it's exactly the same as we did in the previous one. Keyboard arrow up, and down it's just keyboard arrow down, like this. I'm gonna finish, and now I'm gonna have to configure the press and release for each one. So I'm just gonna say left press, it's gonna be a function. I'm gonna point that. You can just write function, it's fine. You don't have to use the arrow, fat arrow one. And now I'm gonna do it in the press is I'm just gonna say explore velocity x. I'm gonna minus that value. I'm gonna give it a negative value so that it goes to the left, that way, the negative side. And -2, let's make it give it a speed of 2. We're gonna make the speed exactly the same as the blobs. If I want to make them harder, I can make the blobs move faster, such as 3 like this. I think that makes sense. And now for the y, it's not gonna move in the vertical axis if we're moving in the horizontal one, so it's gonna be 0. Now for, I think I have space, left dot release. And now I'm gonna have to make sure that the right is not clicked, same as we did in the previous one. And of course I'm not moving vertically, so this have to be 0. I'm gonna give the triple equal, same as we did in the previous one, the keyboard one. And now I'm gonna do simply is I'm just gonna say explorer.velocity x should be 0. And now if I have to copy everything and just do it for the right one, and now since I'm moving to the right, it's gonna be positive. Just move the negative one, and I have to make sure that I'm not clicking on my left. And of course vertical is not moving, everything's fine now. Now let's make it for the up and down, up and down like this one. And now I'm not moving in the horizontal, I'm moving only in the vertical one. It's gonna be negative since I'm moving up. Again, the canvas has an inverse Cartesian for the y, so yeah, if I'm increasing the value, I'm gonna go down. If I'm decreasing, I'm gonna go up. I think I've said that a million times in this episode. And okay, so now if we release one, it's gonna be, I have to make sure that I'm not clicking on my down one, and of course the vertical one, I don't know why I'm using vy, because this has to be velocity y. I think I get confused with the blob one. Okay, velocity y, make sure like this. Now this has to be velocity x, and of course the y is gonna be equal to 0. And now it's gonna be down. Some positive to go down. I'm gonna have to make sure that I'm not going up, so my up is not down. And the velocity x should be 0 since I'm not moving horizontally if I'm moving vertically. And yeah, I think this is everything. And to change that, all I have to do in the game's logic is to alter the x with the velocity one to give us the displacement of this explorer. Simply and now if we checked, I think you're gonna see that it actually moves very nice. To be honest, this is not the correct way to do this with a pixel arted like this characters. We're gonna have to do keyframe animation, but this is kind of advanced for a beginner since every key gonna have its own animation. So if I'm going left, I can see the left side of it. If I'm going up, I can see the back of this player. If I'm going down, I can see the face like this. This is called keyframe animation. I think if you search that topic, you're gonna see how exactly we can do it. But for now, let's keep it that way. Static one movement, very simple. Okay. And now we've done the movement for the player. What we're gonna do now is simply we're gonna move into, let's start contain the player into this area. So I can see now that we can go out. I don't want that, so we can simply use the contain function that we did, and simply I have to specify the first sprite, which is explorer, and now the object. First one is gonna be from 0 till 0, which represents the initial points for this canvas for the field. And now for the width and height to cover the last point of this area, it's gonna be the render dot view dot width. I'm gonna give it a -10. Now I'm gonna show you why. Because when I did the field, okay, let me just finish that one, and -10. Okay, this should be like this, and that should be okay. Syntax errors. Okay, the way I did this is because I want those to be like the borders of my canvas, so that I don't exceed or I don't go out of this. You can see now that I'm actually stopping at the last one. This represents like a wall. I know the design is actually not good. It's really bad, but yeah, this is actually good. Just to contain my player, use the contain function that we did. It's exactly the same. I didn't change anything using sets, and yeah, that is it. And now let's check the collision between these two sprites. Okay, so I'm gonna go into a function. I'm gonna make a function called, let's make it test. It's gonna be function, and I'm gonna call it hit rectangles or hit test rectangles, same as in the book. Okay, hit test rectangles, and I'm gonna have a rect1 and of course rect2. And now I'm gonna leave you with an explanation to how the collision between these two rectangles work, and I'm gonna be back, of course. So yeah. Hey guys, I'm gonna show you now how exactly we can implement the hit rectangles test. So to check the collision between the two rectangles. In our game, they represent the sprites. Either it's the monsters are blobs and the hunter, for instance, or any other two. So these sprites are contained inside a rectangle. To check the collision of these two sprites, we have to check the collisions between these two rectangles. So if I'm having these two rectangles, let's say that I have this one, which is the first rect. It's gonna be rect1. Let's choose another color for the other rect, and it's gonna be rect2, for instance. Let's have a bigger stroke. It's fine. And the way we did this in the Bong, because we've done rectangles collision in the Bong game, and the way we did this is that we specified the cases where there is no collision, and we said else we're gonna have a collision. So if I'm having an if statement here, we're having these conditions in here that I'm gonna say now, and that means our hit, if it's a boolean value, it's gonna be false, and else is gonna be hit equals to true for all of the other things. So the first thing that we did to specify that there was no hit between these two rectangles, so if I'm saying this is rect1.x, which is the initial or the starting value for the horizontal positioning of this rectangle, which is that one, and we said that this rectangle 1x, if it's bigger than the rectangle 2.x plus the rectangle 2.width, which is simply this point. So if I'm plusing the initial point plus the width of this rectangle, it's gonna be this point. So if this rectangle x is bigger than rectangle 2 plus its width, there's gonna be no collision. The other case to that is actually kind of similar. Since we're dealing with the horizontal one, we're gonna say if rect x is gonna be the same, for instance, dot x, and plus the rectangle 1 width, which is gonna be this point, since I'm plusing that one with the rectangle 1 dot width, we're gonna make this smaller than or lesser than the rectangle 2 dot x. I hope that makes sense. It's exactly the same as in Bong. I don't know if I'm explaining this much more clear than the Bong episode, but it's exactly the same. These two cases means there's no conditions if that rectangle x is bigger than this point, and if it's rectangle 2x is much more is bigger than the width with the rectangle x, which is the initial point for the rect x, is smaller than this point. I hope that makes sense. Now if we're dealing with the y is exactly the same. If we're having this y point, which is that one, the initial y, so it's going to be rect1.y, which is the starting point x and y for this rectangle. If I'm having that this rectangle dot y, if it's bigger than the rectangle 2 plus the height, y plus the height, that means that it's under this rectangle, which is like this. This is 2, this is 1. That's rectangle x dot y. It's bigger than the rectangle 2 dot y plus the height, which is this point, so it means bigger than. And the last case where there's no collision is for the rectangle dot 1y plus the width, so that it's exactly lesser than this 2. So this is now going to be 1 and this is 2. This is rectangle 1 dot y plus the height, which is this point, is lesser than the rectangle 2 dot y. I hope that makes sense. These 4 cases are exactly the ones that we used in Bonk to check the collision. But for now, I don't want to cancel everything, and I'm going to show you an easier algorithm that you're definitely not going to forget. So the way we did this is we're going to specify 2 rectangles in here, which is, as I said, okay, let's choose a color for that, which is going to be rect1. Just increase the stroke for that one, and I'm going to have rect2. So the way we do this in here, we're going to find the center of these 2 rectangles. And the way we do it is simply by checking the rect1.x plus rect1.width, which is this value, and I'm going to divide this by 2 to get the center of the first rectangle. The same goes for the other one. I'm just going to say rectangle 2.x plus the width divided by 2. Because this rectangle 2x plus the width is the last point in the rectangle, so divided by 2, I'm going to get the center of these rectangles. So I'm going to get the center x and center y, but make sure that for the y it's going to be the height divided by 2, the y, rect1.y plus the height divided by 2. The same goes for the other rectangle. So now that I got the center x and center y for the rectangle 1, I'm going to get the center x and y for the other rectangle. And now what I'm going to do is I'm going to sum half the widths of these of each rectangle. So I'm just going to say rect1, for instance, I want to get half width, and this is half width is going to be the width of this rectangle that I got from this formula, and I'm going to divide this by 2. The same goes for half height, and I'm going to divide the height by 2. And of course I'm going to do the same thing for the y. Now we have to compare. Before we compare these two, I'm gonna specify a vector, a distance vector, and don't be too confused with the word vector. It's fine. Vector x and y, and for the vector x, I'm gonna minus the center of the first one, which is this formula, the one that we specified in here to get the center of this rectangle, and we're gonna minus that with the rect2 center to get the distance between these two, like that one. This is vector x. And for the y, it's gonna be center y minus the center of that other rectangle. If it's here, for instance, it's gonna be that difference. And now we're gonna combine these two halves simply by simple mathematics. If I'm gonna combine these, the width of these two, I'm just gonna say rectangle 1 half width plus rectangle 2 half width, and I'm gonna get the x half width, the horizontal one, I mean. And the same goes to the combined half heights. It's gonna be exactly the same, but of course for the vertical one. And yeah, simply what I'm gonna do is I'm gonna use the math absolute to get a positive value of this. I'm gonna get the vector distance, the horizontal one, and I'm gonna compare it with the combined half heights or combined half widths. For the case of our horizontal, we're gonna compare this with the combined half widths, like that. If it's smaller than mean, that means there's a collision. We're gonna check for math absolute again for the vertical y, and we're gonna compare it with the height, combined half heights. If it's smaller again, we're gonna have our hit. If there's an else condition, hit will be assigned to false. This is an easier way. I hope that makes sense. We're gonna code that one, and maybe you're gonna understand it more. But I hope this explains it, and I'll see you where we're going to continue with checking the collision of these two rectangles. Okay, hello again, and now we're going to continue with implementing this hit test rectangle function to check the collision between the two sprites, either the explorer and the treasure, or even between the blobs and the explorer as well, the hunter one, and even with the door, since all of them are actually represented as rectangles. So a collision between two rectangles will be the same as the collision between these two sprites. So okay, the first thing we're gonna do in here is we're gonna define some variables. The first one is hit, which is a boolean value which I'm gonna return at the end. So it's gonna be return hit, either it's false or true if I got a collision or if I didn't. And now I'm gonna have the combined half width, as I explained in the previous portion of the video where I'm explaining the collision. Combined half widths, and I'm gonna have the combined half heights to check for the collision. And of course I'm gonna get the vector vx and vy, the distance vectors horizontally and vertically, and we're gonna compare these four variables together, vx and the combined half widths, and the vy and the combined half heights. I hope that makes sense. Okay, now it's gonna be hit by default, it's gonna be false, no collision by default. Now the first thing I'm gonna do is find the center of these rectangles. So the first one it's gonna be center x, simply by going to rect1.x, rect1.x plus rect1.width divided by 2. This is now I'm just gonna copy everything and do, since each rectangle has two centers, the x and y. So now it's gonna be for the y, exactly as I showed you in the previous portion of the video, the collision one. It's gonna be now y and height divided by 2. Now it's gonna be rect2x plus the width divided by 2 to get the center x, and for the center y, simply I'm gonna do the same but for the y and height. So now I have the centers of each rectangles very easily and very simply. The way now I'm gonna do this is I'm gonna get the half width for each rectangle simply by dividing the width by 2. So I'm just gonna say rect1 dot half width divided by 2 like this. I'm just gonna copy now. Half height and rect2 half width is gonna be rect2 width by 2. Now half height is gonna be rect1 height divided by 2. And I think this is very simple, or it's easier than the one that we did in Bong, and I think you can forget that one since it's really an easy approach to the collision. Now it's gonna be 2 and height. So now I got half width and half height for each rectangle. Okay, everything seems to be working just fine. And now I have to give the values for the vector distance. If I want to find the vector distance for horizontal between the center of these two rectangles, so I'm just gonna say rect1 dot center x minus rect2 dot center x to get the vector distance. By the way, we're gonna use math absolute with that one. So if we did rect2 minus rect1, it's gonna be the same. So yeah, we're gonna use math absolute. So it's gonna be now rect1 dot center y minus rect2 dot center y. Okay, that's the distance vector either horizontally or vertically between these two rectangles. Lastly, we're gonna do the combined half widths and height. So I'm gonna get that one. Let's leave it like this. It's gonna be rect1 dot half width plus rect2 half width like this. Now combined half heights is gonna be rect1 dot half height plus rect2 half. I think I know now why not everybody codes from scratch in games, because they take a lot of time and you have to explain every line of code, but I don't think everybody does that. So yeah, and yeah, I hope we got everything. Now we have to compare them very easily. So the first thing I'm gonna do, I'm just gonna say if, and I'm gonna use the absolute in math absolute to get the positive value, so that if we have a negative it's gonna be positive, just the absolute. And I'm just gonna take vx. I have to make sure that it's lesser than the combined half widths. So now we have a collision. Now I'm gonna make we don't have a collision until now, since they collided only horizontally. Now I'm gonna make the check vertically. So yeah, I'm gonna do now math absolute vy, and of course it has to be lesser than the combined half heights. If I got that, that means my hit is true. I got collision like this. Else, okay, that's no. Else it's gonna be hit equals to false. And now I have to make an else for that one also. Hit equal to false. That means no collision in the x-axis, since I am having this first for the first condition, that one else like this, and this is the collision, and this is no collision for the y. So I'm just gonna skim in that one so you can actually understand it more. And this hit that will be returned, it's gonna be a boolean value, either a true or false. I think that is it for this hit test rectangle. Now we're gonna test that one, and simply if we go to the play one, yeah, I'm gonna give it now a let, and I'm gonna give it a let a boolean value. It's gonna be explorer hit is gonna be false. That's between the blobs and the explorer. So I think we need to make the health bar, because we haven't done that. I don't know, I forgot that one. Yeah. Okay, so we have to make it in the setup one. I think it's before the keyboard. Okay, let's keep it that way. I can do it under that one, it's fine. And to make the health bar, this is actually very simple. So the first thing we're gonna do is we have the health bar, and now I'm gonna consider this health bar as its own container like this. Okay, now I'm gonna have position that one simply by setting position, and I can say set for the x and y together. We've gone through that a lot. Now view width minus 100 for instance, let's say, and we can have OI value of 20. That means it's gonna be here for 20. That's for the y. I think for the x is gonna make it start here. I think we should increase that one to make it much further to the back. So maybe we can make it 190 or 200. I think 190 seems fine. That's the value I used for the first the game that you saw in the first one. And okay, so I'm just gonna add this to the game scene. Health bar like that one. Of course you're not gonna see that because this container is empty now, it has nothing. So now I'm gonna have the rectangles that represents the portion of, or the health portions. So okay, so the first one I'm gonna make it an inner bar and an outer one, so that if I lost some blood, you're gonna see that the red decreases and you can see a black one, that's the inner one, and the red is the outer one. If you didn't check the intro, I think you should, to see how exactly the game design works. Now it's gonna be inner bar, which is the black one. So it's gonna be black rectangle, that one. And I'm just gonna say new Pixie, and we're gonna have graphics. I didn't go into graphics, the rectangles and things, because I think it's very similar to Canvas, but instead I think the syntax or the methods has different names, but they're exactly the same. So now the first thing I'm gonna specify is, for now, if I want to draw any graphics, either rectangles, squares, triangles, I'm just gonna have to use the graphics class to make an instantiation of this class. Very simple. And now I'm gonna specify the fill. So I'm just gonna say begin fill to specify the fill color. It's like the fill style. So yeah, I didn't go into the styles or the rectangles because there are a lot. I think you should check the book, but it works exactly the same as in Canvas. So yeah, so now it's gonna be begin fill. I'm gonna give it a color, make sure to use the hex exactly like the hash one, and if I want a black, it's gonna be 6 zeros for the black color, the hex value. And now I have to specify the graphics, so it's gonna be a rectangle, so I'm just gonna say draw rectangle instead of fill rect like this, and of course x and y for the starting points, and I have to specify the width and height. Now this 0 and 0 are gonna be in relative to the health bar. So this health bar has this value as a starting point, which is gonna be the beginning of our rectangle. I hope that makes sense. And now as for the width and height, I'm gonna make it 128 by 8, and I'm just gonna end fill to end the coloring of that one. And yeah, these methods for drawing rectangles and things are very similar to Canvas, with a bit of twist. You can read on that on your own, because I feel like they're easy and they're similar to Canvas. So yeah, and I have to add this health bar, this inner bar into the child, so I'm gonna say inner bar. So the starting point is gonna be the starting point of this health bar, which is the container. Now you're gonna see a black one that goes up. And okay, we have this one. I think we should increase the offset so that we can have, now for the X offset, make it 150. Yeah, so that we don't have it on the health bar. So now if I just refresh, okay, works fine for now. It's contained in a good way. At the end, this is a health bar. It can be on top of any other things. It's not very simple. We didn't move the blobs until now, since we're gonna do that now, but maybe we can finish the outer bar, which simply is the red rectangle. So I'm gonna copy that one, and it's gonna be graphics again, but for the begin fill it's gonna be red. So for the red one, I'm gonna choose a hex value, which is supposed to be FF00 and 00 to give the but I want a bloody red, so it's gonna be a different hex. Making 33 in the green one to make it much more like a bloody red, like that one. And it's gonna be the same thing, but now I'm just gonna say outer bar. And of course I'm gonna use an outer thing. Now we've talked about the painter's algorithm before, that everything that we draw after the previous one, it's gonna be on top of the previous one. So in Canva, in Pixi, we can specify an outer, and I want this to make this the outer bar. By default, since I draw this after that one, it's gonna be on top of it, but just to be sure, we have to specify the outer method to make this outer bar on top of the inner one, so that you can see now it's red. And once we decrease this or we lose some portion of my health, you're gonna see that it goes down and we can see the black one again. Okay, so we're done with the health bar, and now let's make the game over scene. I think it's just to finish with the setup function. Now it's gonna be game over scene. Of course, it's gonna be a new container, same as the game scene, so that we can switch between those. And I'm gonna add it to the stage. It's gonna be game over scene like this. And but so that it doesn't actually come on top of that one, I'm gonna make it visible for now. The visibility of this game over scene visible like this, and I'm gonna make it false, and then I'm gonna turn the visibility on when the end function takes place, when we're having an end state, which means that the game is over. I hope that makes sense. Yes, so let's say game over scene like this, and this is for the health bar. Command one. I'm gonna leave this in my GitHub so you can actually refer to that one. Black rectangle, and this is the red rectangle. Say outer in here. Good documentation is actually good when you're writing code. And now let's specify the message that shows, since I'm actually finishing with this setup function. And yeah, so the first thing I'm gonna specify is a style, just to specify the font family and everything. I told you how to draw text with Pixi in the previous, I think, the previous 2 episodes. But yeah, I'm gonna do it again, but with a different thing. So now I'm just gonna specify a text style, which simply goes into is the other argument of the text Pixi text class or constructor. And yeah, so it's gonna be like this, and I'm gonna have it, and then of course it's an object like that, and have to specify font family. We're gonna use the comic one, since we've been using that a lot. And now for the font size, it's gonna be 64 or 65. 64 seems fine. Now for the red, I want the message to be in red, just like you saw in the intro. And I'm gonna finish now. Now you're gonna see where we actually put the text. So now I'm gonna make a message. It's gonna be new Pixi text, same as we did in the previous one. I'm gonna put in the message in here, which is gonna be the end. I think we're gonna change that after every time, because I don't want to show the end, I just want to show you won and you lost. So okay, let's keep that for now. And then I'm gonna pass in the style, which is simply a text style constructor like that. You can do this, copy that one and pass it into here. It works exactly the same, but that way it's more organized. So now for the X and Y, I want it to be on the center. So again, we do the same thing, divided by 2 minus the message width by 2. Same goes for the Y, but now for the height. Render.view.height divided by 2 minus message dot height divided by 2. I hope that makes sense. And now I'm gonna add it into the game over scene, since I want it to show only when the game is over, either you won or you lost. So it's gonna be the message. And then we're gonna turn this game over visibility in the end state so that we can actually see the message. I hope that makes sense. Now I think we're done with the setup function. Let's check to inspect if we have any errors, everything, nothing. Again, the source maps, I don't know why it moves every time, so I'm just gonna say disable the source maps for the CSS and JavaScript. And okay, everything works fine. Now let's do the collision. Now if I want the Explorer, how about we make the blobs move now, since they're actually not moving. This is very easily to do so, and of course I'm gonna do the first thing in the play, since this contains all of the logic. Okay, so I'm gonna do blobs. See, that's why I'm telling you to specify all of the variables outside of each function, so that they're global and can be accessed in all of the other functions. So now we have this blobs array that we populated with data in this 4 iterations, depending on the number of blobs, and now we have an array that we can do for each method, so that for each like this, so that we can move each blob, and each blob has its own hit rectangle test, the collision test, and the movement is different, and so we can have this random behavior for each blob. And now I'm just gonna say function, and I'm gonna pass in blob as an argument so that it represents each blob. And if I want to move the blobs for now, I'm just gonna say blob.y, since it's moving only vertically. That's why we specified the velocity for that, only vertically, and which is that one that we specified in the for in here. The blobs only move vertically, that's why for the vy, no vx, with a different direction every time, so that each blob, the other one, gonna oppose its direction, so one goes up, one goes down. I hope that makes sense. And now we're just gonna do this with the blob vy. Now if you checked, you can see them moving, but of course we didn't contain them until now. We have to contain the same way as we did for the Explorer. So yeah, you can see them moving in outside of our containment of our canvas. And the way we did this is very simple. So the first thing I'm going to specify in here is, and the way, now if you look at this Explorer, if I try to go outside of the canvas in the other way, I'm just going to stop unless I'm clicking on it. But I want the blobs to reverse their movement. So if one hit the top side, I'm gonna negotiate the y velocity value. So if it's positive, it goes negative, so that it goes down. If it's negative, it goes up. That's the opposite. If it goes up, it goes positive, so it goes down. If it goes down negative, it has to be opposes, so it goes up again. So if it's negative, we're gonna make it positive. Now I'm gonna show you exactly how we can do this. So for that, I'm just gonna make a variable for that. I'm just gonna say blob walls hit. I think it should be blob hit walls like this, and I'm gonna make the contain one, and first one is the blob for each one, which is that one, for each blob like this. This is our sprite, and now we have to make the containment area, or this fixed area that we want. So for now it's gonna be 10. Why it's gonna be 10? Since I don't want them to be on exactly, see, that's the 10, because I want this to present as well. That's why I did it in Photoshop. It's kind of a different, like an edge. I want them to not go over that edge, so that's why these are 10 pixels, and that one is 10 also. So yeah, now for the width and height, it's gonna be simply the same as we did in the, for the Explorer. It's gonna be -10. And now for the height is exactly the same, but it's gonna be the height. Now if I saved, everything works fine. And now I'm just saying if blob hit walls has a value, it means it's assigned with this contain function. I'm gonna make my conditions now. If blob hit walls, now I'm just gonna use has, since this is a set. If you don't know what this containment function is, you should check the previous one. We've talked about contain, we've talked about JavaScript sets and how we can use sets in order to decide for each collision action. So now if I got top, if I collided with the top side of my area or my bottom one, so I'm just gonna say blob hit walls and has bottom like this. What I'm gonna do is just a simple thing. I'm gonna change the y, so I'm gonna divide this by -1, so that if it's positive, it's gonna be negative. If it's negative, it's gonna be positive. So now you're gonna see them moving down the side. So you can see that if I move up, it's gonna go down. If I move down, it's gonna go up. That's for the two cases where they collided up and down using this contain function. So this is a great function at the end. So yeah. And lastly, I'm just gonna check for the collision using my collision function. So I'm just gonna say if hit this rectangle, what did we call it? I think hit this rectangle. Hit this rectangle, yeah. Hit. So it's gonna be hit this rectangle, and I want the collision to be between my explorer and my blob. Make sure that you write this inside of R for each, so that we can access each blob like this. And now if I got hit, I made this boolean value to specify that there's actually a hit. So I'm just gonna say explorer hit, and I get 2, so that if the explorer got hit by any of the blobs, we're gonna decrease its health portion, and of course we're gonna make it half visible by changing the alpha as we did in the canvas for the transparency. So yeah. So now if it's 2, I'm just gonna say if explorer hit is like this, that means it has a true value. Since by default I assign this to false, so if there's a hit between those two, since they are rectangles, they will work if they collided. And simply I can just say if they got hit, I'm just gonna change the alpha for my explorer to 50%, so I'm gonna make it half transparent or 50% transparency, so it's gonna be 0.5. And of course I'm gonna decrease my health bar for the outer, which is the outer bar, and it's gonna be width -1. So I'm gonna have like maybe 8 hits until I die, since we specified the width and height for this rectangle in here. So you can customize all of these things to make it your own version or to make it different. You can do levels, and each level has its own game scene, its own container. I hope that makes sense. And yeah, now let's make an else statement. That else we want the alpha of this explorer to be 1, so that it's fully opaque, no transparency. So now if we try to test that one, okay, there's something to be wrong with our rectangle in here, because we haven't updated that one, I think. If we check that one, okay, width -1 is gonna be health bar outer. This is not working, I think, because check that one. Okay, if we go up and check for the health bar, so that we see we did this in a good way. Now we're having our health bar. Where is it? Okay, this one. Okay, we didn't change that when we copied. That's why it's not actually working. I don't know why I did this. This is a silly mistake. Just gonna copy that one, and now you're definitely gonna see the health goes down, or we lose a portion of our health like this. Nice. And every time we hit, we go half transparent. Until now, you can see that doesn't go until the end, so I have to make a condition for that if it's lesser than 0. So I'm gonna go if, an if statement for that, simply by just going here and just saying if health bar outer, which is the outer bar, width is lesser than 0. What I'm gonna do is simply I'm just gonna change my state to end. That means I lost or our health is done. And I think we should change the message.text. We can change that one to you lost. Since this function in the state just turns the visibility of my game over scene visible to true, so that's actually visible, and then it's gonna show the message. And if we change the message text, you're gonna see the you lost. You can change the end. So yeah. And now we're gonna make it the case we want, and that only happens if I took my treasure and I go back to the door and there's a collision between my texture with this treasure and this door. I hope that makes sense. So let's check the collision for hit test rectangle, and now I'm gonna make it between my explorer and my chest, which is the treasure, so that if they collided, I want to take my treasure to make it stick with this explorer, so it feels like I'm actually carrying this one. So I'm gonna go and I'm simply gonna make the treasure.x to be my explorer.x plus 8. Since this is actually a 16 by 16, so if you look at this explorer, this is 16 by 16 I think, and 8 is simply just the half of this, or so that it feels like you're carrying it with your right hand. You can increase this to 12, it works fine. But yeah, so that the treasure y moves with us, it's like we're carrying it with our own hand. This is like the position of our hand in the explorer. The x is the initial point of this explorer, and plus 8, it's gonna feel like this in here. I hope that makes sense. So now if we test that one, if there's collision, I'm gonna carry that one, and the x and y for this rectangle is gonna be like it's on with our hands. And now we have to make sure that these two collide with the door, so that we won for this case. This is really a simple game, and it has a lot of good things that you should know. And yeah, so I'm just saying if now hit test and treasure. It's gonna be, wait, let me just start that again. It should be treasure and door. Since this treasure wouldn't move by itself, I have to carry it in order. I think there's something going in here. Yes, like this. Since if you look at this, the treasure doesn't move, so if there's a collision between the treasure and the door, that means I moved this treasure with me to that one. So if I carried that one now, I think we just change this state to end, and I'm gonna say you won. Lost. Just capital that one. You lost. Okay, so now if I got my chest or my treasure like this and I move to the end, you're gonna see that I actually won when it detects the treasure in the door collection. I won. Okay, since we haven't changed the background, I think this is a better way than erasing everything, but I think we'll stop that one. But I think we should check that one in the end, because we haven't done the last part, which is simply should be game scene dot visible. We have to make it false now, so that we don't see the game, we only see the one thing. So now I'm just gonna take it. Of course this is easy now, but you can increase the number of blobs, you can increase the speed. I'm gonna show you now how you can do this, and now I won, and I made my game visible. That's the good things about containers, and I think this is the game. Yeah, if I check now for the collision, I'm gonna make myself collide with all of these blobs so that I can lose. Okay, last hit, I lost. If you like this to be to make the game scene like this, just check now if I died, and I'm gonna die again, so that the game scene is still visible. I don't know, it depends on you, but I felt like, okay, I think this looks nicer, but I'm just gonna keep that like this. And yeah, so if you want to make this harder, you can simply go up there and you can increase this number of blobs. You can say 15 for instance, if make the speed goes to 4, so it's double the speed of our explorer. So now try to do it. I think it's gonna be difficult, so now I'm just doing okay. I think you can make levels with this one. It's gonna be fun when there's levels. And okay, I think I did it, which is good. And okay, let's make an expert level for instance. You can make it that with game scene. You can just say 20, you can say 5, and it's gonna be really difficult. Now because of the spacing exceeds our canvas, you can see that it doesn't, but you can increase the offset so that starts from this one and I think this is very difficult to do, so I'm gonna take my chest. This is a suicide mission. But okay, I got it. I think this is the last one. I'm just gonna kill myself. Alright, this is the game, and I hope you enjoyed this episode and this series as well. And I'll see you in the upcoming series if I did one, but I think they're not gonna be web related ones. Maybe they're gonna be C++ or Java, so I'm not sure. So I hope you like this series. If you have any questions, please leave a comments. If you have any if you want to talk with me, you're gonna ask any questions. I have a Twitter account and an Instagram as well, and there's a Reddit, a subreddit for my channel. And this is, or you can simply just leave a comment in a comment under this video or any videos, and I'll definitely reply to that. And I hope this series was as much informative as it was fun for me, because it was so much fun. And I'll see you again in any other episodes or any additional or bonus episodes in this one, but I'm not sure. I'll see you.